That's gonna be the base of our next generator.
Okay.
That's printing right now in the Take building.
It's printed?
Oh, so you're doing that as a 3D excursion?
Yeah, it's being printed in 3D. It takes 2 hours to get it done. We have to go back at 5 to pick it up.
Oh,
Professor King helped us print it today.
No, Professor Kim put it down?
Yeah.
3D? Nice.
Is that for the
generator?
Huh?
That's which one? Yeah, this is gonna go. We made
Oh,
one
you haven't
generator.
seen the other. Oh, we have before.
We have videos.
We have a
show
generator
him.
before of that, but we have to pull it apart because we're gonna do a new one.
I had to pull it apart so I can get the dimensions to move it off so we can put stronger magnets in the center. So we try to create more voltage. That's the new base for it. So this is two of them, one in top and one in the bottom. That current generator with 20 windings, it produced 1 voltage at 450 RPM. This one with 38 to 40 windings, it produced 2 voltage. So it doubled because we doubled the windings of the thing. This is another generator called Frankenstein. Do we have Frankenstein? No, that one's out too. And that one produces 2 voltage with only 180 RPM. So it kind of almost quadruples it, right?
No, the problem is that was manufacturing. We bought it, so
It was pre-made, so we put it together.
and then it's put it together, and he could get the amount of
That's why
voltage.
it was kind of better at producing voltage, but it has a lot of torque in the center.
We couldn't
so
we
it would
couldn't
be very
figure it
hard
out.
to start.
We couldn't figure it out which one was better because it takes a lot of torque in order to start it.
This generator has no metal on it. The only metal is the one in the center that holds the magnets and the screws that holds the bases together. That's the only, and even that has torque. When you try to turn it, you can feel the pull of the magnet pulling the screws pulling on it.
Like if you turn it like that with your finger and you put down the computer, you will see that. You will see the electricity. Or if you hook up that to the
Drill.
not to the drill. If you hook up that to the
When he gets angry,
Oscilloscope?
no, to the circuit. If you hook up that to the circuit and you put the LED on it, you will see that the LED will light. Pretty cool.
From spinning.
We bought it like
This is the
like 36
blades,
bucks.
and right here is the generator.
We're right here in New Jersey, and we're in Bergen. Paramus have an average wind of 10 miles per hour. So we cannot make like a like a
Very
huge
heavy blades because it wouldn't even turn.
It wouldn't even turn. Well, basically, okay, the windmill is not gonna be like you're gonna put it right away to your house and it's gonna give you light. The only way that you can use it is you can store energy, like a battery. That's it, and the battery is gonna store the energy. So you just can be accumulating a lot of battery right there, a lot of energy in the battery. That's it. You can use after that energy there. That's basically how you're gonna store energy.
And this is our solar dome project. What it is it's a solar concentrator, and what it does is it takes sunlight and it reflects all the sunlight to one area so that area heats up. And our goal is to cook hot dogs with this solar concentrator. So as you can see, we got all the mirrors here. All these mirrors here are going to reflect the sunlight up and heat this Arizona iced tea can. And in this Arizona iced tea can, we're going to cook hot dogs. On the bottom here, we have our base. Right, this is to make sure that we can hold up our solar concentrator, and it tilts around the base so that we can change the angle with respect to the sun. Because if the sun's high in the sky, we need to have it facing up. If the sun's setting, we need to have it vertical to the ground. In the future, we're going to build a very large version of our solar concentrator, and we're going to boil water, and that's going to power a heat pump, and that heat pump is going to heat up a room. So far with this, we've achieved 305 degrees Fahrenheit. We're hoping to achieve at least 451 degrees Fahrenheit. So far for what we want to do, we've already achieved the temperature. We're already working on alternative forms of this project, such as, say, a dish-shaped parabolic dish, and that will allow us to concentrate even higher temperatures than what we've already accomplished. But these are going to slide in here like this, and they're going to bend into a parabolic shape so that we can concentrate the sun's energy. We're, again, still looking at more and more designs. We're still trying to figure out what our final design will be. This is like going to be our second prototype. We've pretty much already accomplished our first prototype, and we already know that everything works. So I think so far this project has been a success.
These are really nice. They're drum. This is a drum braking system. It's not caliber, obviously, because that'd be extremely expensive. But they're pretty. They're really nice, and they work really well. Also, it helps us out.
And you want the rivets to go like you have it, from the inside out?
Yeah, the reason is because we asked Professor Sontag about that. The reason we're doing it for the wheel well on the outside this way is one, because we're not sure if the tire will hit those and possibly explode the tire. So we want to keep them on the outside just for the wheel wells, but probably for the rest of the car we do it at the reverse.
It's kind of cool, but it's sticking out.
I know, I said that. I was like, you know, this makes it bad, you know? Like, pretty much, you know, in order to work on stuff, you have to make sure everything's pre-done, you know? Before you put, everything's got to be perfectly set up. It's okay, it's interesting, it's fun. So when it's done and you see me on, you know, Midland Avenue doing 35, 40, wrecking it, right?
Okay, so I'm Professor McCurry. This is my student Isha, and Isha and a few other students are working with me to build a cosmic ray detector. And cosmic rays are high energy particles from outer space. They can come from the sun, they can come from other stars, they can come from higher energy sources like background noise in the galaxy. And so what we're going to be doing is building a machine that can detect those particles once they interact with Earth's atmosphere.